Hello everyone, let's look at this number theory question together. So over here we have m and n, which are two odd numbers, and n is less than m. So we need to find the largest integer which divides all possible numbers in the forms m squared minus n squared. So we can write m as the form as 2p plus 1 and n in the form of 2q plus 1 because m and n are odd numbers. And no matter what numbers p and q is, if you multiply that number by 2 and add 1 to it, it will be an odd number. So p and q just represent any integer. P and q are integers. So we can express m squared minus n squared in p and q. M squared minus n squared is equal to 2p plus 1 squared minus 2q plus 1 squared. And we can use the identity a squared minus b squared is equal to a plus b times a minus b. So this will become 2p plus 1 plus 2q plus 1 times 2p plus 1 minus 2q minus 1. So we will have 2p plus 2q plus 2 times 2p minus 2q, because this one and 1 cancels out. So we have 2 times p plus q plus 1 times 2 times p minus q. So we have 4 times p plus q plus 1 and p minus q. So right now it seems like the largest integer which may divide all possible numbers is 4, but that's not the final answer, so don't be fooled. So we now need to do casework and consider the following cases. First of all, we can have p and q are odd, or we can have p and q are even. So then we have p minus q is even because an odd number subtracted by odd number or even number subtracted by even number is both even. So if p minus q is even, we can factor a 2 out of it. So the largest integer which divides like this expression is actually 8. And in another scenario where we can have p is odd, q is even, or we can have q is odd and p is even, then p plus q plus 1 is even as well. So we can factor a 2 out of this term in this expression, and the answer is 8. So in conclusion, the largest integer which divides all possible numbers of the form m squared minus n squared is 8. And that's the video for today. I hope you learned something new and enjoyed the process.